Hey guys, this is Taylor and today we are solving second question of biweekly contest 165. So let's read the problem. You are given two integers W and M and integer array arrivals also where this arrivals I represent the type of item arriving on day I and days are one indexed. Items are managed according to the following rules. There are some rules. Each arrival may kept or discarded. An item may only be discarded on its arrival day. So we can keep the item, we can discard the item, but discardation should be happen only on that day itself. For each day, consider the window of days, this term, and the explanation of this term is the W most recent days up to day I. Okay, we will understand this thing properly. For any search window, each item type may appear at most m times among kept arrivals whose arrival days lies in that window. If keeping the arrival on day I would cause its type to appear more than m times in the window, that arrival must be discarded. Okay, it is the minimum number of arrivals to be discarded so that every W day window contains at most m occurrence of each type. Let's understand the problem what is given to us. So first of all, we need to take a window size of 4. So if you don't understand what is window, so if I draw something like this is 4 window, this is window of 4 size, this is also window of 4 size. If I take any random example, let's say 2 window size, so this is window of 2 size, this is window of 2 size, this is window of 2 size, something like this. Okay, we need to maintain a window. Okay, second thing, in this window, in this one like 4 size window, the occurrences of each element should be less than equal to m. So if you see in this window, one occurrence is 3 times, two occurrence is 1 time. Is it allowed? Yes. Is it allowed? No, because m is 2. I can have at most 2 occurrences. One would be fine, two would be fine, but this is 3, so this is not fine. So what I am supposed to do here, let's say if I pick up this window, so I will let's say I have kept this, I have kept this, I have kept this. For example, we have problem, right? We either need to keep it or discard it. So let's say for example I have kept this three things. Now I will check for this. Will I keep it or not? For that I will check what is the in the window size. In the window size, what is the occurrence of one? So it will tell me 2 is the occurrence. So this 2 is already equal to m, right? So I can't keep it. So I will discard it. I will not take it. Okay, I will not take it. Now I will move here. I will move here. But if I move here, I will not take this window. I will create a new window, something like this. I will create a new window, something like this, and then I will check. Okay, what is the occurrence of one? I think occurrence of one is this one. Occurrence of one is only this one. So as you remember, we discarded it, right? So we will not increase the count here. So one occurrence is one, two occurrence is I think one, only one. Okay. Can I consider this 2? Absolutely, I can consider. I can have at most m equal to 2. So definitely it will become 2 and I will definitely keep it. So just to give you one more example, uh, 1, 2, double, triple, 3, 4. Okay. 1, 2, triple, 3, 4. Window equal to k equal to window 3 m2. Okay. Window 3 m equal to 2. Superb. Now, let's try to create a window size of 3. So first window size will be something like this, right? In this window size, what is okay, wait. So I will start from here. I will start from here. What is like, am I considering window size of less than equal to 3? Yes. So can I consider this element? So for now, my window contains 0 elements. My like nothing is like before this nothing is there, so everything is empty. So definitely I will consider this one. Okay, so I will consider this. Super. Now I will move here. Now my frequency dictionary or I have to make frequency array, frequency dictionary, whatever you say. So I will make a one count was came one time. Okay, super. Now I am here at 2. I will check. Is it causing an issue? Is what is the two occurrence? Two occurrence is 0. So it is not present in frequency dictionary. That means it's 0. So I can definitely take it. I will make it 1. I will take it. Super. I will go here. What is occurrence of 3? I think 3 occurrence is already 0. So I will keep it. Keep it. Super. Now I will go here, and once I will go here, I will remove this part because for this, I have to consider window size of 3. So window size of 3 will something looks like this. I think this will be the window size looks like for this. So I will only consider this. So 2 came one time, 3 came one time. Okay, now I'm at here. I will check whether I can take this or not. So my m is equal to 2. Definitely I can take it. So let me update it to 2. So I have kept this also. Super. Now I will come here for this 3. When once I am reaching here, window will be this part. This 3 elements will be my window. Super. Now I will remove this. Okay, before starting, I will remove this because this is not coming in my window. Super. Now I will check key whether I can put this 3 or not. So my frequency of 3 is already 2. My m is equal to 2. That means maximum possible element is 2. So I will discard this. So I will not take this. Super. Now I will go here. I will go here. But before this, what I will need to do, I need to update my window. So my updated window will be something like this. Maximum window size 3. Superb. Now, if you carefully observe, uh, I will remove this. I will make it 1. I will make it 1. Now tell me, in this window size, what is frequency? I think 3's frequency is 2, 4 frequency. Like, let's not talk about 4 because we are currently present here. So 3's frequency is 2, but still our window, our frequency dictionary looks like this. 3, it's telling 1. Why it is telling 1? Because we haven't used this. We haven't used this, right? We discarded it. So we should not update this here. So this is very important thing about this problem. I hope this problem statement question explanation is clear to you. So can I take this 4 or not? Absolutely I can take this because 4 frequency is 0. So I will take it 4 frequency. I will make 1, and this will be my dictionary. This will be my dictionary looks like, okay, or HashMap or frequency dictionary, whatever you say. So this will be my state of dictionary. I hope this question statement is making sense to you. So how we can solve this problem? Let's talk about some intuition. So what you can see one thing. Every time we need to maintain a frequency dictionary, right? So first thing is I'm very sure, okay, I need some frequency dictionary. So for first thing I'm sure of. Second thing, I need to keep track of elements. I need to keep track of elements whether I have kept it or discarded it, right? And I need to count the number of discard elements. But to make this algorithm, but to perfectly calculate the count of discarded elements, I need to keep track whether I have kept this element or discarded. I have keep or discard. I have keep discarded. So if you can see, we got a 3 here, right? So just for example, 1, 2, 3, 3, 3, 4, and let's say 3 again came here. Okay, 3 again came here. Now if you see, let's say our window size equal to 4 for example, and m equal to 2. Okay, now uh, when I will be here, will I take this 3? No, I will not take. So I will discard this. So this 3 is discarded. Now let's say I reached here. Okay, for this 3, my window size is what? I think this will be my window size. This will be my window size. If you carefully see, our frequency of 3 is equal to 1. 4 frequency is 1. So can I take this? Absolutely I can take this. But we have discarded this. So we will not count this in this frequency dictionary. These things we need to make sure we do this correctly. If we do this correctly, we can definitely do this. So the intuition we can do this is, maybe you can, like, the idea I can give you some hint. I can in Leetcode solution section, you will not find the solution because this is more optimized than every solution. I have like checked all of the solutions. I didn't find any solution like this. So what is my solution is, what you can do is, instead of making a set or some other data structure to keep track whether you have updated this element or you have kept this element or discarded it, what you can actually do is basically make it negative. Okay, make this element a negative. Okay, and what you will do, uh, so I think that much hint is sufficient. So just to keep track whether you have kept that element or not, you can you can modify this existing array. You can make those elements negative, and I think you can keep other things, keep track of other things. So if you didn't get the solution, don't worry. Okay, let's discuss about the approach of this solution, exact solution, and we will be try running it, and simultaneously we'll be learning how we can solve this problem. So I will maintain a count variable which will be representing my answer, how many elements I have discarded. Superb. So my frequency element, frequency dictionary will be initially empty. I will reach here. I will check where. So if you carefully see, my m is equal to 1, window size is 3, I need to take. Okay, so I will allow only one frequency of each element. Okay, in my window. Super. So my frequency array is empty. Definitely I can keep it. I will put it. I will make it one. Super. I will go here. I can see 2 is not present. I will add 2. Super. Now I will go here. I will check, is this present? Yes, it is present. And my m is equal to 1. Its count is 1. So m is reaching. Target is reaching. I can't add 1. So I will quickly update this thing first of all. Super. Now I need to do something so that I can keep track that I haven't used this. So what I'm doing, I am making it -1. I have made it -1. I have just uh, done something like this, nums of I equal to -1 into nums of I, -1 into nums of I, something like this I have done, so that I can keep track of things, ki what is what element I have kept, what element I haven't kept. So this will help me in future. Okay, so I will just like to update this example, maybe like this, 3 1. Okay, yeah, okay, fine. Now okay, so my frequency dictionary will not be updated, but let's say I have reached here. Super. Now, do I need to update the frequency dictionary? Because my current window will be this, right? My current window will be this. So I need to update my frequency dictionary. How I will be updating? I will check whether I have kept this element or not. So I know one thing for sure, that this is my current I, 0, 1, 2, 3, 4, 5. My current I equal to is equal to 3. My window size is also equal to 3. So what I need to remove? I need to remove this zeroth element, right? Zeroth element. So I will be doing something. So index, I got it, is I minus w. This will tell me which index I need to remove. Okay, so I definitely have to remove this, but before removing I need to check whether I have kept that or not kept that. So if this is positive, so if you see the constraints, we have only positive numbers, right? We have only positive numbers. Super. So if this number is negative, that means I have discarded it. If this number is positive, that means I have kept this. So I will say, okay, this number is positive, so I can definitely remove this. Super. So instead of marking it 1, I will make it, let's say I will make it 0. Super. So this will be my current window looks like. Okay, this will be my current window looks like. Super. Now uh, I will definitely include here, because 3 frequency is 0, so I will make it superb. Now I will go here. I will check. What I will check? Can I take this one or not? So I will check the frequency dictionary. It's telling me one's count is 0. Maximum allowed is 1. I can definitely take it. So before that, I forgot one step. What we need to do? We will be calculating new index. Index will be I minus W. I equal to 4 here. 4 here. Okay. So I will be 4 minus W is 3. So 1. I need to remove this one index. But before that, I will check whether I have kept it or discarded it. This is positive. That means I have kept it. So I will make it 0. What I will be doing? I will be reducing -1 frequency. I will be doing frequency -1. Okay. I think that will help us while coding. I will tell in detail. So okay. Now I will say Okay, what is the frequency of 1? So it is clearly telling me 1's frequency is 0. Why it's telling me 0? Because this 1 we haven't kept, because we had discarded, because we already had 1 here and in this window, so we had discarded this. So by calculating this window, this discarded wala thing will not make my this one not eligible. This is definitely eligible. So definitely I can say I can definitely take it, and I am don't have to discard anything. So next thing I need to take, can I take these three? But before that, I again forgot. So I need to check. Very important step. This is unique step. So current I is 5. I equal to 5 here. So 5 minus W is what? 3. 5 minus 2 is 3. So 5 minus 3 is 2. I need to remove this 2. But before removing, before updating the dictionary, I need to check whether I have kept it or discarded it. This is negative. That is telling me, okay, I haven't kept it. I had discarded it. So I will not update anything in my dictionary. Okay, I will not make this 1 0. Okay, otherwise you will get wrong answer problems. So I will not do anything. Now I will go here. I will check what is the frequency of 3. It's already 1. Maximum allowed is already also 1. So I will not take it. I will make it minus 1. I will make it minus 1. So I hope the approach is clear to you. So this is pretty simple problem. If you have worked on sliding window, if you know sliding window properly, and you can observe this thing, how you can keep track of index, whether you have kept it or discarded it. If you can keep track of this thing, this is very simple. So what other people are doing basically, they are trying to have a separate array with this all indexes, and they are making marking 1 if they have kept it and marking 0 if they haven't kept it. But that is costing us another order of n space. But this space you can do it little optimally. You can avoid this extra overhead space overhead. So that is definitely this solution is a little optimized version. So let's talk about the pseudo code. So pseudo code spelling I don't know actually. So I hope you understand. The pseudo spelling I don't know. So first of all, I will take the length of my nums array or arrivals. I think arrivals are given. Arrivals, okay. And equal to length of arrivals. Super. Now, what I need to do, I need to make a dictionary, and that will be the only space that will be having frequency dictionary, nothing else. Okay, super. Now, okay, do I need to take anything? I don't think. Super. Let's start. Okay. So I will be going like this. For I equal to 0 to n minus 1. Okay. Now, what I need to do? I need to check if, first of all, if my uh, I is greater than equal to window, then only, if this condition is true, then only we will check whether we need to discard some element from left side. So let's say I am present here. My window size is equal to 3 and my current I equal to, let's say, 1. Do I need to remove anything from the left side? No, I don't, because my window size is already small, right? If let's say my window is like this, do I need to remove anything? I am at 2. Maximum allowed window is 3. This size is also 3. Do I need to remove anything from left side? No, I don't need to. But let's say when I am here, do I need to remove anything from left side? Yes, I need to. Why? Because my window size became 4, but maximum allowed is 3. Super. That's why we are doing here. I greater than equal to W. What I need to do in that case? I need to check if uh, so let's assign index first. Index equal to what we were doing here, I minus W, right? So I will be doing similarly I minus W. Now what I need to do, I need to check if arrivals of index is greater than 0. In that case, yes, I need to update dictionary, update, or maybe I can update like this. So D of this arrival of index minus equal to 1. So whatever the frequency is, I will just reduce by 1. Simple. Super. Now, what the next thing I need to do? So once I have updated this, let's say I am present here. I have removed this from frequency dictionary. I made it 0. what I need to check whether I can add this 3 or not. If I can add this 3, I will not update my counter. If I am not able to take this 3, I will update my counter to 1, or let's say increasing it. Okay, super. No, what I need to check, I need to check the current frequency. I will be checking current frequency of I will be d of arrival of I. So here I was taking index, here I'm taking I. Don't get confused, okay? I will check if current frequency is less than M. If in case it is less than M, then I can definitely add it. So I will just check definitely D of arrival of I can update by 1. Okay, I can update by 1. And the next thing what I can do is I think that's it. That's it, right? But in case this target I'm not able to assign it, I'm not able to take this, so I will maintain a counter variable which is initialized from 0. I will make counter plus equal to 1 or counter plus plus, whatever you say. And next thing is I will make this arrival of I equal to arrival of I into -1, so that I can keep track of this thing here whether I have kept it or not. So I have marked it. Okay, I am not taking it, so I have marked it like this. Now in the end of the day I can just simply return the count and my task will be done. I hope this solution is clear to you. Let's try to code this up. If you have any doubts, just let me know in the comment section. So dictionary will be initialized from empty and will be, I think, length of arrivals. Superb. Okay, counter we need to initialize as 0. Now for I in range. Superb. I need to check first of all. What is the first thing I'm doing? If I minus W is greater than equal to okay, is greater than equal to 0. Okay, in that case, what I need to do? I need to update. I need to remove the left part. I need to remove the leftmost part. But before removing, I need to check whether that is basically the positive number or not. So index will be I minus W. I will go. I will check if arrivals of index is greater than 0. In only that case, I will remove this arrivals of index minus equal to 1. Superb. Now, current frequency, I will calculate d of arrivals of I. So I will check if current frequency is less than M, then I can add it in my dictionary. D of arrivals of I equal to d of arrivals of I, or maybe I can do like this, d dot get, just to avoid some extra errors. So by default, I will be getting a 0 value if that is not present. Otherwise, I will be getting whatever the frequency of that. Okay, I hope I don't have to explain this part. You know HashMap dictionary very well. Now after this, if I'm not able to take it, I will increase my counter, and the next thing that I will be doing is I will make that element as -1. We will multiply it with -1. Super. In the end of the day, I will just return the counter. Let's try to run this. Okay, key error I. Okay, yeah, I need to take a get method also here, because let's say if that element is not present, I should be getting a 0. So if that element is not present, if we start the iteration, this one is not present, right? So we should get a 0. So that means it's not present, right? So everything else looks good, I think, right? Let's try to run this. Okay, it is working fine. Let's try to submit. Maybe it is correct. Yes, it is accepted. So I hope guys I'm able to explain you this sliding window and little tricky problem. The trick was just to make sure how you can keep track of those elements which you have kept or discarded. So thank you very much guys for watching this video. I'll meet in the next one, and please make sure you subscribe to the channel for the next question. Okay, thank you.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase and leave.